All right, grade 12s, welcome to your lesson on interpreting the circles. Like we will be finding the intersection of circles in analytical geometry. So I hope you do enjoy this lesson. So let's get started. So look at what we've got this time around. I want you to look at this point right here when we have two circles that intersect at one point. Now I want you to look at how the graph looks like. So notice if the two circles just touch, this one actually they touch at one point. So if they touch at one point like here, it's about the distance between the centers. So what you are only expected to do is to know the center of one circle and also the center of the other circle. If you have the two centers of the circle, you can easily calculate the distance AB, as you can see on this diagram right here. So if you can use the distance formula, it doesn't necessarily have to be horizontal. It may be a vertical distance, but if you have the coordinates of A, if you perhaps have x1 and x and y1 here, and you also have the coordinates of B, maybe it's x2 and y2, it doesn't matter where they are. You can use your distance formula to calculate the distance between the two centers of the circle. Well, if you do that, if you calculate AB, notice if two circles touch at one point, just like now, notice how the radius of each circle, you see, let's say you perhaps had the radius of this circle, the blue part from here to there, that's R1. I think you're seeing it. And then you also have the length of the radius of the second circle, which will be called R2. All you really need to do is to add that R1 and R2 and compare it to the distance AB here. As you can see, if these two are exactly equal, I mean, if I were to ask you to calculate this distance AB and compare it to the distance of R1 and R2, you can really see that they are exactly equal here. So if this case that we find here is satisfied, we say that the circles are touching. They touch externally. It's important that you see that it's actually externally. Because when it's internally, this whole AB now just becomes R1 minus R2. You hardly use this at all. If they touch internally, they'll look something of this sort, and then another one will be like that. So that will be touching internally. You hardly get questions such as this, but remember for them that to touch internally, that is the condition that will be satisfied. Okay, so now you may be wondering, how is this important to me? How does it get asked? But before I go to how it gets asked, you may be already confused about me talking about AB, distance AB. So it's important for you to see the difference between this distance AB and the sum of R1 and R2. Look at your second page here. This time around, you can see that they are intersecting. They are not touching. On the left-hand side, you can see they are touching, but over here, it's clear to us that they are actually intersecting. So if they are intersecting, the overall distance between A and B, okay, the overall distance between A and B, let's put it here. If you look at this side, this part here, excuse me, okay, is no longer equal to R1 plus R2. In fact, you can see that it is small. The diagrams themselves are self-explanatory. That is why I made sure that you have them. So in your head, combine the blue line for R1 and the red line for R2 and compare it with a straight line distance between A and B. That way you will appreciate that AB in this situation happens to be smaller than R1 and R2. So that is when we know that two circles intersect at two distinct points. So those are the things I want you to know before we start answering questions. And lastly, one more thing that I want you to know. Look at these circles. here at 3. Now, look, the blue A with the center A, the blue circle with center A and radius R1, and the second one, which is over here, with R2. Now, look at how the distance AB now, AB is definitely bigger because you just combine the two. So if you move from here, like that, you should find that that distance AB is greater than R1 and R2. And if that is satisfied, that is when you can say two circles intersect. Rather, do not intersect. Okay, I think you're looking at your notes here. So if the circles, they are not touching, they are not even cutting, they are not intersecting at all. So AB is supposed to be in this situation greater than R1 and R2. It should be easy to see. But you see, if we just talk about math, it becomes a problem. Let's do it. Let me show you how you use this information to actually calculate a few things. So here I have a question with me. We already have a circle, which is going to satisfy condition 1. We have this circle over here. Now we can start working it out. We're going to call it center A, so let's write down center A. From what you know, the equation of a circle is written like this, so you remember that very well. Okay, so at this point, you can easily appreciate that in place of xc, there is 3. So that's the coordinate of x at the center. And then for y, there is -2 over there. So that is the coordinate of A, the center of the first circle. And let's call the radius of this, the length of the radius, let's call it R1. We know that 25 here is representing R squared. So it means R itself has got to be the square root of 25, the positive 1, which is just 5. So you put it over there. Well, let me do the same for the second circle. I'm going to call the center of the second circle, I'm going to call it B. And if I call it B, it's going to be 12, and that one is going to be 10. So I hope you're here now. And the radius, let's call it R2. Just square root of that 100. That should be 10. Now, from what I said, you simply have to compare the distance between the two centers, the distance between A and B, to the sum of these two here. You just add them. So let's go ahead and calculate the distance AB. In fact, the question asked us to do so. So I'm going to just do that quickly. Remember the distance formula in case you forgot. Let me quickly put it up. It is our x2 minus x1. Let me just do that. It should be x2 minus x1 squared plus y2 minus y1 squared. Okay, this is our distance formula. So let's calculate AB properly by substituting. So this is not a problem for a child in grade 12 that we know. So it's going to be, let's say 12 minus 3 squared. I'm calling these our 2's and those ones are our 1's. And 12 minus 3, then 10 minus 2. I'm just going to write it as 10 plus 2 squared. As you can see, if you do it properly, you will get AB as 15 units. You can use your calculator, it's really not a problem here. And then, when you get your AB, your distance AB, now you have the value of the distance AB. Now get the length, get the value of R1 plus R2. If you are looking at them, it's just a matter of adding these two. So it is 5 plus 10. Well, as you can see, 5 plus 10 happens to be 15. In this situation, our AB is exactly equal to R1 plus R2. And if AB is equal to R1 plus R2, we know that the two circles just touch. And it's important to mention that they touch externally, right? You have to say they touch externally. And if you have forgotten, I have your notes up here. You can always refer to them. Okay, so here is our condition. For them to touch externally, the distance AB must be exactly equal to R1 plus R2. So that is good. It does look like that was easy to prove, so I hope you get the point. All you need to do is to get a distance AB, and then you find your R1 plus R2, and then you carry on. So let's find out what we can do here with AB. For this one, I'm going to call this circle with center A, this one. So the center there, which is A, I'm going to call it, it's going to be -2 and 1, right? And here let's get R1. R1 is square root of 25, which will be 5. I think you're following. Let's get it. It's here and there. So as you can see, in this situation, my B, the center of the second circle, will be 1 and 3. And let's find the radius, which is going to be R2. In this situation, it is 3. So I am going to have to show that the circles intersect each other at 2 distinct points. So if they intersect each other at 2 distinct points, remember we said this is the condition that must hold. So let's go ahead and do it. I'm going to calculate AB. Make sure that in this situation, AB, all you need to prove is that AB is smaller than R1 plus R2. That's all there is to it. So since we already know the distance formula, I'm not going to waste your time. So we're going to say -1 minus 2. Let me rather start with saying -2 minus 1. Okay, x2 minus x1 plus y2 minus y1. In this situation, it is 3 minus 1 squared. So as you can see for this one, if you properly use, you can use your calculator. It's not an issue. So you should be able to get, there is 9 there. Okay, it's square root of 13. That's what I got. Check if you've got a different one and see if maybe you have the same one. It will be fine as well. So I'm getting 3.61 to 2 decimal places here. So that should be easy to do, really. And let's find our R1 plus R2. It's 8. So since R1 plus R2 is 8 and AB is 3.61, it's clear which one is bigger than which here. At this point, we can really conclude and say, well, AB in this situation happens to be smaller than the sum of the radii. So as you can see in this situation, I can then say, therefore, circles intersect at 2 distinct points. Easy peasy. Okay, good. Now, there is a small problem, okay? This is a bit of a problem right here. Determine the equation of the common chord. So before I answer that question, let me rather go and answer the next sum where we are still applying this, and then come back to this question. Don't forget it's there. So at this point, I want us to do it. Let's look at this one. So it does look like it has been messed up a bit here. Okay, now you can see the question without any problems. So look at these 2 circles. You're going to have to show that these circles determine whether or not the circles having these equations will intersect. Okay, let's see what will happen here. The center. You must be pros at this point. And then for this one, It is 5 and negative 1. And let's get R1. It is 5, square root of 25. And square root of 9 is, it does look like we have managed to get for our circle, for ourselves, circles with center with the same radius, actually, like the previous one. Okay, well, now you know how to calculate distance AB. I'm not going to waste your time here. Let's write it as 5 plus 2. And then y2 is negative 1 minus y1. I'm going to do it like that. So if you are looking, quickly calculate that one and see if you have the same answer as me. I'm getting some square root of 74. I hope that's the same one you're getting. And if I round it off, it will be this many units. And luckily for us, if we go and calculate R1 plus R2 here, notice it will just be 5 plus 3. That is 8, isn't it? Now, if in this situation, one can see that AB happens to be greater, actually, than R1 plus R2. So, what condition is this? And as you can remember, it is this particular condition that we've got. So if AB is greater than R1 and R2, we know that the circles do not even touch. They don't touch, they don't intersect, so this is what we've got. So circles do not touch. They do not touch, neither do they intersect. Okay. Right. So now that one is sorted. If you are given 6 marks for that, honestly, you will love life, won't you? Now let's figure out what happens with that common chord of ours and also the common tangent. Those ones can be a bit of a drag kind of question, so let's go for it. You remember it was over here. So just for the love of it, I'm going to erase everything here. Let's erase everything over here. I want to determine the equation of the common chord. Let me just tell you this. If you want to determine the equation of the common chord, let me show you what I mean. When we say common chord, we mean the line that passes through. You see, these circles are intersecting it at 2 places. So there is a line. If I draw a line such as this one, let me use this color. So this line. Okay, I hope you can see it. At this point, that line, if I let it go, it will be a common secant. So for it to be a common chord, I may have to stop it over there and stop it over there. So the line that I drew over there, it's a chord to the red circle, and it's also a chord of the blue circle. That is why it's called a common chord. They share this particular chord together. So now how do we calculate the equation of a straight line? We know it's y is equal to mx plus c, but for this time, we don't have the gradient, we don't have a coordinate, so there's got to be another way of solving it. And all I may tell you now is you just need to equate the 2 equations of the circle. So all you need to do is to equate the equations of the circle and you're sorted. So what do I mean? Okay, so make sure first that the equation of the circles that you've got, which is this first one and the second one, make sure they are equal to 0 or to the same thing. What I mean is just really see the first one as this. Okay. If you do this, do you see it will be equal to 0 now? If I take 25 to the other side. You can do the same with the other one, x minus 1. In fact, you can expand it in as well. These brackets, get rid of them. You can do it in one step. You see, now both of them are equal to 1, isn't it, to 0. So it means you can call this one equation 1 and another one equation 2. Then you can solve them simultaneously. Because they are both equal to 0, it means I can really equate them like this. The top equation, you can really just equate it to the bottom equation. Okay, it must be simple to do. I'm sure you're done with that one. So I managed to equate the two. So since I equated them, now I'm free to expand. So as for expanding brackets that are squared, I think you find that very simple. So let's go ahead and do it. This one will be x squared plus 4x plus 4, right? Then the second one, y squared minus 2y plus 1. And don't forget that negative 25. Oh, you don't want to forget it. Then this side will have x squared minus 2x plus 1. It is not a problem expanding this, plus y squared minus 6y plus 9, and then there is that negative 9. So if you do it right, there are some things that should cancel at this step, such as y squared and y squared. On the other side, the 9's cancelled easily. Look at x squared and this x squared cancelling. So everything else will actually cancel, and you will be able to now express y in terms of x. Remember, that is the equation of a straight line. You just have to be able to express y in terms of x. And here we are already at that step. So let's go ahead and quickly do it. Okay, so this one will be 4x plus 4. Let's have 4x. There is a. I think if we just say 4x, and then that one would be plus 4 minus 25. Let me simplify that one. We're gonna do it a bit slowly. It should be minus 2y. And then 4 plus 1, that's 5 minus 25, should be negative 20. And then on the other side, let's see, you see, taking these things, we still have that negative 2x, and then we have that plus 1 and minus 6y. Okay, I'm going to take everything to one side now, like taking y to the other side. Notice I would just have minus 2 plus 6, I should have 4y. And then 4x plus 2x, I should have 6x. And then negative 20, let me take it to the other side. I'm going to just write it as 21. It should be like this. So 4y plus 6x is equal to 21. As you can see, it's already the equation of a straight line. You can leave it at this point, it's fine. Or if you want to really make y subject to the formula, you can first of all you can do this. There is no need to make y subject at this point. But if you feel like it, you can go ahead and do this step where y, negative 6 over 4 will be negative 3 over 2, isn't it? And 21 divided by 4, we would just kind of leave it like that. So this will be the equation of the common tangent. It's a common tangent. Excuse me, or this one is a common chord where it's actually cutting. So here my head is already thinking of a common tangent. When do we have a common tangent? That is when they actually just touch. If they intersect like this one, notice what we will have is called a common chord. A common chord. Well, since we talked about a common tangent, it's only fair that I should show you how that is done. Let's come to this one quickly. This one. So I'm going to quickly go through this one. This particular one. Let's find, do you see that they're just touching? So since those ones are just touching, it means we can be successful in finding the common tangent. So I'm going to go through it easily. since you already know what to do, I'm going to equate these two equations, that one and that one, but after I have taken 25 to that side and 100 to that side. So let's go ahead and do it together quickly. So I'm going to say x minus 3 squared plus y plus 2 squared minus 25 is equal to x minus 12 squared plus y minus 10 squared minus 100. See, I did that step. You know which step I did? Equate them to 0 first, and then equate the two equations. So I'm going to FOIL now. This is child's play. So you agree with me there, right? Then plus y squared plus 4y plus 4. And then there is that negative 25 we don't want to leave out. And then next on the other side, let me use this color here, is equal to, now we have some big numbers, that is negative 24x plus 144. And then we still have y squared minus 20y. Let's have plus 100 and then that negative 100. Couldn't fit it in there. Luckily these two cancel. So, and x squared will cancel, y squared and y squared will cancel, and let's get this answer going. So I'm going to write it as negative 6x. Well, 9 plus 4 minus 25, that should just be negative 12. But let me write that plus 4y first. So that will be negative 12. And this here will be equal to negative 24x plus that 144. We can see it, and then that minus 20y, we don't want to forget it. Okay, so to finish it off, let's simplify this and we will have the equation of a straight line in no time at all. If I simplify this, I should have 24y. You see, if I take that one to the other side, and I should have positive 18x. You're seeing how minus 6x plus 24x when it goes to the other side. Okay, that's saying something about time. Okay, then plus 156 over there. So to simplify this, I'm going to say 4y plus 3x is equal to 26. Please, people, this will be the equation of the common tangent that you have. So this is all we've got for these intersecting circles. I hope you keep these notes in mind and keep studying. All right, this is what we've got, and I hope to see you soon and enjoy everything. Thank you very much.